Hello, amazing fans. Welcome to today's maths class. Today we want to look at binomial theorem. Okay, so let's digest it with this question on the board. So we are asked to expand x plus y raised to power 5. So in our algebra, we are meant to understand that when we want to expand brackets like this, they're going to give us like this scenario. We have x plus y, then you multiply it to the number of times the power that you have up there. S plus y, then x plus y, then x plus y. How many? 1, 2, 3, 4, then x plus what? Y. Oh my God, I'm going to be multiplying everything. Multiply, multiply, multiply. This is going to be so rigorous. All right. Well, today, let us look for a very short way of what? Expanding this. And that is why we have what is called what? Binomial theorem. So in binomial theorem, it's divided into two. We have the use of what? Pascal triangle. And we also have the use of the use of what? Combinatorial coefficients. Or you can call it what? Combinatorics. Okay. So now we are going to make use of either combinatorics or the Pascal triangle. So this one is what? Rigorous. I disagree with that. Okay. Now let us look at how we are going to expand this. But before we expand this, I want to give you something, a general way that you can know what you need to have. Now you need to have the expansion, then you look for the coefficients. The use of Pascal triangle is to derive the coefficient of each term. Look at now. If I want to expand this now, I'm having x and y. So if one term is increasing, then while the other term, the power will be decreasing. So I'm going to be combining every one of them. And you remember that in mathematics, every digit begins at what? 0. So we have 0, 1, 2, 3, 4, then t infinity. Now, it means that what? X or this has to start from the power of 0, which means either x or y must first of all raise to 0. As this one raised to 0, the other one will raise to what? The highest power. So that is how it's going to look like. So in this case now, the power of y will be what? Increasing. Since this is the what? The second term. While the first term here, the power will be what? Decreasing. Let's go. So which means that I'm going to start from x raised to power 5 because it's going to raise to this. Then y raised to the power of 0. Good. Because this second term, the power will have to be increasing. While the first term here, the power will be what? Decreasing. So in our next term now, I'm going to have x raised to power 4. Okay. Then y will increase by 1. Why this one is decreasing by 1? So we're going to have what? Y raised to power 1. Good. Now the third term going to give us what? X will be decreased by 1 again. This particular one will be decreased by 1, which is now what? X raised to power 3. Then why this one will increase by 1? Have what? Y raised to power 2. Good. So let's go. The fourth term, x will be decreased again by 1. We're going to have what? X raised to power 2. Then we have what? Y raised to the power of what? Of 3. Good. Then this is the what? Fourth time. Then we have plus x raised to power 1 here. Okay. Then y will be raised to power what? 4. Y the last one, x we have to raise to the power of 0. Then y raised to the power of 5. So now, having this at the back of our mind, how do we then know the coefficient of each term? There has to be a coefficient, a coefficient, a coefficient, a coefficient, a coefficient. So since we already know this is how the expansion is going to look like. So that is why Pascal triangle is very important. So we are going to use Pascal triangle to derive all the coefficients here. So how does Pascal triangle look like? We are told that what in algebra, remember that we have x plus y here. If I have x plus y, now the power has to start from 0. Okay, it must begin from what? 0. And we are told that whatever raised to the power of 0 is going to give us equal to what? 1. So which means if I have x plus y raised to the power 0, it means that the coefficient of both x and y there is 1. Good. Now let us look at here, this is where x raised to the power y is equal to 0. Now, how do we form this triangle? This particular one that you have here, what you do, you bring it here, okay? Okay, you bring it down. Now, this particular one, you are going to add it to this, which is 0, because we don't have any number here. We don't have any number here. You add it to this, you add it to this, which means I'm going to have 1 here. Okay, I have 1 there. Then I bring another 1 here again. You close it up. Now, let's go. This is where x plus y raised to the power of 0. And this is where x plus y raised to the power of 1. Good. Now, let us go. Now, how do we get the next coefficient again? This one here, bring it here. That is 1 plus 0 is 1. Then 1 plus this one, put it here. That is what 2. Okay. 1 plus 1 is what 2. You add it to this next one. 1 plus 1 is 2. Then 1 plus 0 here, you bring it here. You close it up. You close it up with 1. Then this is where x plus y raised to the power of 2. Good. So now let us go to the next one. 1 here again. 1 plus 0 is what? 1. Then 2 plus 1, you're going to have of 3. 1 plus 2, you're going to have of 3. Then this 1 plus 0 here, then you close it up with what? 1. So which means we are going to have, this is where x plus y equal to 3. Raised to the power of 3. Now let us go to the next one. 1 here, 1 plus this one, 0 here, 1 plus 0 here, is going to give you what? 1. Okay. Now take this one to add it to this one. 3 plus 1 is what? 4. Now 3 plus 3 is what? 6. 1 plus 3 is what? 4. 1 plus 0 is what? 1. Then close it up. Right. So this is where x plus y raised to the power of what? 4. Remember, we are going to what? Raised to the power 5. So here, let's move. 1 plus 0 here is what? 1. Okay. 4 plus 1 is going to give you 5. 4 plus 6 here, 6 plus this 4 gives you what? 10. Then 4 plus another 6 again gives you another 10. Okay. 1 plus 4 is what? 5. Then 1 plus 0 is what? 1. We close it up. So this is where x plus y raised to the power of what? 5. Good. So it means this is the coefficient we are going to what? Take to what? Place it in this our expansion. Very easy. So we are able to derive, look at it now. This is why we call it a Pascal triangle. This is a triangle. It has a triangular shape. See that? Look at the shape. Goes like this. Goes like this. See that? So this is a triangle. So here we are going to take this one. We have 1, 5, 10, 10, 5, and 1. So we place it here. It means that the first time here is going to have 1 as a coefficient multiplying it. So y raised to power 0 is what? 1. So when they take this over 0, so we're going to have our x raised to power 5. Okay. Then plus, yeah, x raised to power 4. The coefficient here is your 5. We're going to have 5 x raised to power 4, then y. Good. So let's go plus the next term there is what? X raised to power 3 y squared. Then the coefficient should be what? 10. Well, 10 x raised to power 3 y squared. Then plus the next one is what? X raised to power 2 y raised to power 3. Then the coefficient is also 10. 10 x raised to power 2 y raised to power 3. Then the next one is 5, which is the coefficient of this. Now x raised to power 1. X raised to power 1, which is what? X. Then, okay, we put the 5 there. 5x. Then y raised to power what? 4. Then x raised to power 0 is 1. Then we have what? Y raised to power 5 plus y raised to power what? 5. So this is the answer. So when you expand this using Pascal triangle on binomial theorem, so this is what we're going to have. X raised to power 5 plus 5x raised to power 4y, then 10x cubed y squared plus 10x squared y cubed plus 5x y raised to power 4, then plus y raised to power 5. So this is what is called Pascal triangle. If you find this class very interesting, please don't hesitate to share this video so that you can get to greater number of people across this platform. Bye.